So I'm going to drop Cybertrack. I already transferred this file from that old programmer computer to here. I'm going to drop it in Hue. The numbers that we punch in manually appear right here. 0.5, 0.5, 0.5, 0.5, 5.5, etc. Right? You get the idea. And right here are the hex values for all those numbers, and we're gonna enter the hex data into the other program. So I'm gonna exit this, and we're gonna bring 2010 specs. So let me rename this as Cybertrack, just to identify the folder, and drop it right here in Hue again. Now this is the original EPROM, and we're gonna modify. Instead of Toyota, we're gonna substitute this as Tesla, and we'll do all caps on that. So let's do all caps Tesla, and then we don't want that. Update the file F9. There you go. So it updated to Tesla. That's no problem there because you can just type it, right? From there, go to the address 897E. And it brings us to the first Toyota Avalon. We're gonna substitute that to 2020. Go to here, and then we'll put Cybertrack, and we update the file. Now we come here to the pointer, which is 9F0C, 0C. And it'll take us to the pointer, and that's where we're gonna install those hex values as we have it on the whiteboard. And this time we'll keep it there because if we go to the ASCII, we're gonna change the symbols, enter in the hex data, right? We start with 01F4, 4, and then 01F4, 01F4. That's 1, 2, 3, 4, 01F4. And then there'll be 157C. 157C, 0.4, F4, and then 0.2, 0.2, then 0.4 times, 0.2 times, and then it'll be 0.000, 04, 01, and 1F, FF. Those are the values for the variables. So as you can see highlighted in yellow there, those are the same symbols that we just got from the RAM. So that's how we can actually get the right alignment data punched into it. So we're gonna update this file, and it's ready. That Cybertrack file or binary file, we're gonna send it to the programmer, and we're gonna edit the checksum with the programmer editor. So that's to be next. I'm gonna load the binary file to the buffer using number 2. And I gotta select right here on the C drive, and I am already in the MU folder right here. So I'm gonna go all the way to the end of the file, and I got Cybertrack there, and also Cyber. And the Cybertrack is when we read the RAM on that chip, and the Cyber is the actual EPROM that we modify. So I'm gonna select that one, and I'm gonna open it as a binary file, which is B. Load the address all the way to the from the beginning to the end. Now I'm gonna edit the buffer. If you notice, there's a checksum, and the checksum should end in 00. So somehow I have to get from C to 0 and from A to 0. So I have to like remove or add some characters on the file. Let's see, it's kind of complicated. So let me go to the 4. I'm gonna display the buffer here. So edit the buffer. So we're gonna go all the way to the end of the file, and this is kind of like limited right here because it doesn't have a control end right here. It just doesn't do anything. So I have to keep pressing the pitch down key until I get to the end. As you can imagine, this is kind of like time consuming here until you get it right. However, you do this only once you modify all the data on the EPROM. Then you just look for correcting the checksum here at the end. So I have to go all the way to the end
E, F, F. So this is the end of the EPROM right here. 1F, FF. That'll be the end of, I think, no, FFFF. This is the end of the EPROM. So, and I can remove 1F. Let me see. If I remove 1 and put 0, that's only one space, right? So, let me see. But I can remove 4 right here. So I put 0, 5, and then, oh man. Well, I already messed up there, but let's see what happens if I remove those. And then I'll escape it, quit. Now my checksum changed to A469. I like 7 zeros. I need to add like 1. So let's see. Number 4. Get it? So we're gonna have to go all the way to the end again, and that's the end. So we need to remove 1. 1, 1, 1. So if I put 3 here, and then see what happens. Good. It was actually add 2 instead of remove 1. So I had to add 2. So let's see, number 4, and edit the buffer. Actually, it wasn't 2 because it's hexadecimal. So that was actually 2 plus another 6, right? So that was 8. So I already added 2. So I need to add 6. So I'm gonna add 3 here. And I'm gonna add another 3 here. See what happens. Quit. There you go. So it's A470. I'm gonna play a little bit around and then see if I can remove 7 from there. So I'll be right back. Very well. So I was playing with the hex data at the end of the file, and I got of A400. This checksum will be accepted by the C111 once we program the EPROM, see if it works. So the next step is to actually erase an EPROM. Okay, so I just peel off the sticker of this EPROM. It's a Corp 127C512 ST. So I got the eraser turned on. You can see the light like shining there. And I got my timer right there ready. So we're gonna drop it in and just press start. I got it set up for 10 minutes. So we're gonna wait until it finishes. All right, we got it. Put it on the programmer here. And we're gonna see if we can check for blank. So blank check is number, it's a B. Ready to check, yes. Checking, and it checked okay. Now we can actually program it, and I hope everything goes well, because if it doesn't go well, we have to put the EPROM on the eraser another 10 minutes. Let me go ahead and program it. So it's a P for programming, and see if we can program it. Oh, program error. So something happening here. So let me blank check it again. Check it. Okay, so now something messed up. Is I had to erase it again. So this is very time-consuming stuff. Go ahead and start this again. Let's do it again. Okay. There it is again. 10 minutes. Let me check, see if it's blank before we try again. So blank check, yes. Seems like it's okay. So it's a blank EPROM. So now let's try this again. I didn't have the brand SGS Thompson on it. I had general EPROM and the type. So maybe this was the problem. Hopefully it will program it. So let's try it again. P. And then ready to program, yes. Okay, so I think it's programmed it and it's verifying it and it's okay. So finally what I had to do is I had to change the program speed to flash, and that seems like it did the trick. Okay, so the first thing I had to do is I need to put the RAM back on the socket there. Make sure it's pointing the right way. Make sure all the pins are in, otherwise it won't work. Alright, so remove the current EPROM that has got the C111 2010 specs, and insert that right here on the socket. I hope I got all the pins in it, otherwise it's not gonna work. So now let's turn this machine around here. Well, let me turn it on and hopefully everything will work. I hope it works. There you go. Well, it seems like it's working. Spec memory. There you go. Oh, here it is. Tesla. There you go. And there you go. That's the Cybertruck. And that's our specs. So it did work. So I'm glad it did. So we got now a Tesla 2020 Cybertruck with the specs that we program in it. And this way we can do all of them if we put some time into it. Alright, so this is gonna wrap up this long process. We were able to actually program one single car into the black EPROM, and we learned about how to manipulate the data and how the data is organized on the EPROM. So we could actually use the same machine to decipher the invisible or special characters on the EPROM and convert it to hex data. We also learned how to modify the checksum, so the machine will take the EPROM. I went through all this process 10 years ago. With trial and error, I was able to figure out all this. It took me a long time, and I was starting to forget how I did it, so I kind of wanted to put it in video. So for in the future, if I would like to do it again, or maybe somebody is interested in doing it, then the video is there, right? So alright guys, so thank you very much for watching this long video. I hope the content was informative, or at least entertaining for you. Please don't forget to check out my other videos about the C111, and if you like this kind of content, please give it a thumbs up or subscribe to my channel. Don't forget to ring the bell so the videos get to you, and I will see you next time. Bye bye.